And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at the southern hemisphere of the closest star here. 3 sunspot groups in this area right here. Sunspot 2818, Sunspot 2820, and Sunspot 2821. All in that same clump of sunspots. It's 335 angstroms, one of the ionized iron wavelengths from the Solar Dynamics Observatory. Here's an even closer close-up. So today's daily space weather video will be talking about space, a frontier, sunspots, climate thoughts, and the coronal mass ejection. Sup with it. Sup with that. What's up with the forecasting of it? Okay, and here is the southern hemisphere in magnetogram. And it looks like sunspot 2818 has grown a little bit here in the last 24 hours. That's this leading group right here. This is sunspot 2020, and this is sunspot 2821. So 2818, 2820, and 2821, all in that same area there. Likelihood of solar flares has gone up as the Earth-facing quiet zone is ending, as the sun is moving out of the exact Earth-facing zone. And that increases the likelihood of solar flares. Also, some possibility for coronal mass ejection still exists. We'll keep you posted on that as well. Here's a full disk view in ionized helium, 304 angstroms, and you can see there are quite a few filaments here once again. This little filamentary dance you're seeing in the southern hemisphere down here does not appear to have ejected. That must have collapsed back down onto the surface of the sun there, the chromosphere, or maybe just the lower corona, but in any case, does not appear to have ejected, at least not in the Earth-facing vicinity. You can also see some filaments in the northeastern limb up here. But a great view of that little unstable filamentary dance happening right there in the southern hemisphere. Here's a visualization of the solar system. Did you enjoy the pink supermoon last night? There's where we expect things to be in 1 week. Are you a lunatic? Have you discovered that your menstrual cycle is correlated with other women? Have you noticed that your menstrual cycle is correlated with moon phases? Here's an article on SciTech Daily about it. And since our internet is down while I'm recording the video, can't really show you the article. Here's a star chart. And this yellow line is the ecliptic. The moon is still visible where I'm located. And it was near the apex of its flight across the ecliptic last night at 11:32 p.m. was the moment of the full moon for Eastern Daylight Time. The pink supermoon, the radial flux, currently at 80 solar flux units. This black line up here is the 1-year chart of that. You can find that yourself at solon.info. Don't take my word for it. And here is the Enlil forecast model here from NOAA. And I don't know what's going on. It's not showing the coronal mass ejection at all yet. Basically, a totally worthless forecast model here. We're expecting the coronal mass ejection to impact the geospace in about a little over 24 hours. Not exactly sure why there's nothing listed. Maybe these people are on vacation. I have no idea. You can see no forecast for an increase in geomagnetism at all. I would staunchly refute that forecast. Largest earthquake of the past 24 was this Tongan Quake. Actually, it's in the Kermadec Islands region. Kermadec Trench here, one of the most seismically active regions in the past year or so. Let's run down the list. No major quakes over the past 24 hours. Nothing higher than a 5 magnitude. So you can see there was a 5.2 near New Zealand, a 5.3 near the South Sandwich Islands. That would be this one down here. That was actually a 5.8, so nearly a 6 magnitude quake there. And we just had this site shut down as well as a result of no internet. So in other news, Fagradalsfjall is indeed still filling up its crater valley, as you can see in this imagery. Let's check what other volcanoes have been erupting over the past 24. And it looks like we're unable to do so, as again, no internet. It's still a great time to remind our viewers to not pole vault the caldera, a public service message from smAsho.com. Next, looking at the GOES X-ray flux, and we don't see any major solar flares here, although a background B level. And no surprise there, as we've got 3 sunspot groups facing the Earth. No spikes in the proton flux, and no surprises there. We're not expecting a major spike. We may see a little spike in the proton flux when that coronal mass ejection arrives, although I doubt it. And here's 3 days of the GOES magnetometer. We show it daily at the Smash News Network. Least busted. Name in news. Next, the heliospheric current sheet. And you can see the Earth's potential field surface source line, shown here in orange, is solidly in the middle of a North Pole-oriented current sheet, shown in green. And we expect the Earth to remain there for the foreseeable future, at least for a few more days. Here's another view of the same thing. It's the line of sight ecliptic plane field plot. Essentially a 3-dimensional visualization of that same data, showing you a bit of a visualization of the heliospheric current sheet. Here's the line of sight coronal hole plot, and I'm not sure why it doesn't show this coronal hole, but there is indeed a coronal hole in this area, right in here. Not sure why it's not showing it, but we can clearly see it in 193 angstroms. We'll show you toward the end of the video a little bit of imagery on that. And I think our internet connection is back. So let's go back and see if we can reload VolcanoDiscovery.com's Volcanoes Today page, which looks like it has not been updated. So maybe we're seeing some communication errors, folks. Here, I'll show you the page. So there's Volcanoes Today. It's showing yesterday. Sakurajima, Popocatépetl, and Revenador shown to be currently erupting. Let's get back to where we were. And so here you can see sunspot 2818. I think I had the wrong numbers there, folks. 2818 is actually this one. This one back here, that's 2818. 2021 is actually this one, and 2020 is this one. I hope that helps. They're all very close together. It's behaving like one sunspot group, pretty much. And here is the KP index currently at 3. And for you new viewers out there, the KP index is a measurement of global geomagnetism. We did see a brief period of geomagnetic storm early in the day yesterday. Next, the real-time solar wind. Current conditions are solar wind density just under 4 protons per cubic centimeter. Solar wind speed remains elevated here at 496 kilometers per second. And it's creating some pressure. Here's a 4-hour magnetosphere movie. It's based on the space weather modeling framework. And it's courtesy University of Michigan. We show it daily because the archival data is not yet publicly visible. We hope that will change and that they will add a data archive access feature to this so we can more easily show coronal mass ejection, geomagnetic storm impacts, coronal hole impacts, and so on. Coronal hole wind stream impacts. Next, looking at ground magnetic perturbations, here are geospace delta B, changes in the Earth's B field. Whenever you see the word delta in science, that means change in. This one is measured in nanotesla. The last one was measured in nanopascals. So pressure, this is magnetohydrodynamic flux density. Nanotesla. And we show this one daily as well because we are living through a polar excursion. The Earth currently has 2 geomagnetic north poles, and the south geomagnetic pole is thousands of miles from the south geographic pole, someplace south of Australia in the southern Indian Ocean. Next, I would invite our Twitch viewers. Let's stream live to Twitch. Welcome to our Twitch viewers. And we're now streaming live to Twitch for our cosmology segment. Before we get into that, thanks everybody who views the videos on Twitch, twitch.tv/smAsho. Thanks to our BitChute subscribers, as well as our YouTube subscribers. Please press the subscribe button if you're not already a subscriber to the channel. Press the share button if you haven't shared the video on your social media. Tell your friends, foes, and science noobs and science pros about the channel. And let's do a cosmology segment. Should be an interesting one today. Starting out with the story about LINDS 1523e, the cold, molecular, and starless core. So this blob of molecular material here, known as LINDS 1521e, was recently observed using the ARROW 12-meter telescope. And we're not exactly sure what we're seeing here, but it's not understood how these complex molecules are here. How is it doing this with no star at the core of this area? So we've got some interesting molecular structures in there, including dimethyl ether, methyl formate, vinyl cyanide, and various transitional states. What's going on in this cold molecular cloud? Well, the answer is we really don't know. The detection of rich complex organic molecules chemistry in young cold core L1521e represents an interesting challenge for future modeling efforts, requiring some type of unified approach combining cosmic ray chemistry, reactive desorption, and non-diffusive surface reactions, the astronomers concluded. So perhaps check this one out. It's in the phys.org's Astronomy in Space section. And if you want to look this up yourself, you can actually find L1521e, although you won't find very much, as again, it is a dark molecular cloud, so if you're not viewing it in radio frequency and so on, it's going to look dark. So IRIS is actually infrared. You're not going to see anything on the 2 mass either. You're not going to see anything on any of these because, again, it's a dark molecular cloud. You can see the 2 mass showing next to nothing when it comes to infrared light. And next on our list is the astronomy picture of the day. So this one's not my favorite. It's an animation. It's an artist's rendition of a black hole tidal event, a massive radio source devouring a star, so to speak. And it's a pretty cool visualization. You can see the torus forming here, as well as the poloidal jets blasting out. It's a model of what may happen during a tidal disruption event when a star has its atmosphere siphoned into the quote accretion disk and quote of the massive radio source, which people commonly would refer to as a black hole. Here's a close-up of what some people think you may be seeing if you were inside the torus with a fairly close-up view of the, quote, event horizon, end quote. And now a pan up to one of the poloidal jet regions. And next I'd like to talk about the Faraday Effect. Are you aware of the Faraday Effect? The magneto-optic Faraday Effect, where light is affected by magnetism, especially at cold temperatures in a medium. Well, if you haven't heard about the Faraday Effect, it's probably something occurring in space. What do you say? Leave us a comment. Let us know what you think about the Faraday Effect. Or have a read on the Wikipedia article if you like. Were you aware that light can be stopped entirely? So it was big news when they slowed light down to 38 miles per hour. After that, they stopped light entirely. So Einstein theorized that light cannot travel faster. But what about slower? It appears to not travel at a uniform speed through a medium, especially when associated with a very strong magnetic field. So perhaps check out this article from the Harvard Gazette. The title is, Researchers Now Able to Stop and Restart Light. So basically what they did here, folks, is they had a laser and a magnetic medium through which the beam of light passes and a sensor. And they were actually able to have light passing through the magnetic field, turn off the laser, turn off the field, and find that light found its way back to the sensor. So light was paused, folks. They stopped light entirely in this experiment. It's kind of serious. And if you weren't aware, we're more than happy to bring this to your attention. They shot laser beams through a dense cloud of rubidium and helium gas. The light bounced from atom to atom, gradually slowing down until it stopped. No super vacuum or ultra cold was needed. In fact, the chamber where the light stopped was at a temperature of 176 degrees Fahrenheit. Only half of the incoming light was stored, and the storage time was shorter. So in any case, perhaps check this one out. It's pretty interesting. And again, the title of the article is Researchers Now Able to Stop and Restart Light. Let's talk about the interstellar medium. Frankly, we don't know what's going on out there. The Oort cloud is a theorized area, as well as the Kuiper belt. It's an explanation for where objects are coming from. Are they outside of the heliosphere? Are they inside the heliosphere? Well, there's a new project proposed, and by the year 2045 or so, we may actually get some answers to this. So check out this article. It's from SciTech Daily, Probing Deep Space with a New Interstellar Spacecraft. So there's a new object about to be, well, in the year 2030. The Interstellar Probe, a new proposed, I guess it's already in development here. The Interstellar Probe will go to the unknown local interstellar space where humanity has never reached before. So this has got some interesting stuff about cosmology and so on, as we don't even know the shape of the heliosphere or very much about what's going on in the interstellar space out of it. Is the sun approaching the edge of the local interstellar cloud? What is outside the interstellar cloud? What does it mean to approach the edge of an interstellar cloud? What does that really mean, folks? And the answer is we don't know. But I'll say this, unique heliophysics and science opportunities along the interstellar probe journey up to 1,000 astronomical units from the sun. An astronomical unit is the distance from the Earth to the sun, corresponding with about 93 million miles. Another interesting scenario happening here. And what is the shape of the bow shock? What is causing the bow shock? What is the directional aspect of the incoming protons? What's going on in interstellar space? It's a very important question. as maybe it gives us insight into things like heliophysics. Today we're not going to pick a random number at all. We're going to look at a totally non-random object. The brightest intrinsic object in the Milky Way galaxy, at least visible from our solar system. It's Cygnus X3, yes. Here it is in the Chandra X-ray telescope. What we were looking at there was the infrared on the Glimpse 360. How about on Pan-STARRS? Here it is in color. It's a high-mass X-ray binary consisting of a massive radio source orbiting a massive star, a blue supergiant known as a Wolf-Rayet star. And it's a pretty violent place. It's one of the most powerful X-ray sources, and it's one of the only known cosmic ray point sources. And check it out, folks, over the past few days here, the past about 6 days, we saw a very dense series of outbursts once again, and X3 is currently in its X-ray loud state. We're trying to get radio astronomers to take a look at this, as if we catch this in radio frequency during its transitional mode between its X-ray loud and X-ray quiet state, it'll probably give us additional information about the nature of the jet that is connecting all the way from Cygnus X3's poloidal field to your brain. Yes, it's true, folks. It's sending cosmic rays directly through your brain from a disputed distance of somewhere between 2,000 and 8,000 light years. Cygnus X3, the brightest intrinsic object in the sky, the star Deneb, part of the Summer Triangle. And that's today's cosmology segment. We'll have to say goodbye to Twitch until we return for the meteorology segment. Next, we're talking about electrons. And we saw a precipitous dip in electrons here over the past couple of days. There's the 1-year chart of it. Here is the 3-day chart of the electron flux as measured by the GOES 16. Back into pretty low levels of electron flux, transitioning from about a week of warnings every day. And electrons can cause charging hazards. We show this most days as well. Some minor charging hazards here currently over places like the Caribbean, Mexico, Central America, Northern South America, the Central Atlantic, and Central Pacific. Here's the electron forecast model. And you can see the observations pretty close to the forecast here, shown as the green box. No comment on that. And here is the here's a visualization of the Van Allen belts. We show this daily as well to help people understand what they're looking at. These Van Allen belts are full of a soup of various different molecules, ions, etc. And they're sort of surrounded by bands of electrons traveling at relativistic speeds. When satellites communicate with the ground, they are forced to communicate through all of those electrons, and that causes GPS errors, which is what you're seeing here in the total electron content forecast. It will show you where GPS errors are most likely to occur, which is typically around the equator at noon. However, when we see chaotic electron belts, sometimes we see anomalies at places besides around the equator at noon. We show this most days on the daily space weather videos as well. And you can see some nighttime anomalies happening there, places like South America. Here's another diagram of the atmosphere. It's showing you the F layer. And it's to set us up for the next frame, which is the animation of the ionosphere. Let me scroll down a little bit. It's 15 minutes per second, folks. Each tick of the clock here represents 15 minutes. And we see a little bit of an irregular shape here happening over places like Africa. I would remind our viewers that we have two very weak spots in the magnetosphere. One is about here. It's the South Atlantic anomaly. And one is now down here as well, the South African anomaly. The South Atlantic anomaly has recently split into two. And there are two very weak spots, the South Atlantic and South African anomalies, the two weakest portions of the Earth's magnetosphere. Here's the latest image. That's from 8:30 Universal Time. Ionosphere looking pretty normal there to me. And welcome back to Twitch. Let's take a moment to talk about climate. Climate, yes. Climate. It's going to be a new thing featured here at the Smash News Network, least busted name in news. What's going on with the climate? Oh my God. Blueberries in Maine are experiencing global warming faster than other parts of the state. Now, you're going to see an influx of ridiculous and nonsensical stories. And the point is, folks, a warmer planet is not scary in any way, and a colder planet is capable of destroying civilization as we know it. Let me just repeat that. There's nothing scary about a warmer planet. The Minoan warm period featured a massive boom in civilization because of ability to farm areas that were unable to be farmed previously because of a thing known as an ice age. Now, you're currently living in an ice age, since both poles of the planet are frozen all year round. The sea ice isn't gone. It doesn't look like it's going to be gone anytime soon. The idea that it is going to be gone is absolutely ridiculous. The Earth's rotation speeding up is an indication of global cooling, as the equatorial bulge shrinks from things like more snow and ice being deposited at the poles or colder oceans. Colder oceans take up less volume than warmer oceans, which decrease the size of the equatorial bulge, and decreasing the size of the Earth's equatorial bulge slows down Earth's rotation. Speeds up Earth's rotation. A larger equatorial bulge creates more centrifugal force, which slows down the rotation of the planet. A smaller equatorial bulge speeds up the Earth's rotation, and 2020 was the fastest spinning year since the 1960s. So here's a story from phys.org. Phys.org's Earth section is full of sharticles about climate. So here's one attempting to frighten you and make you believe nonsense about the climate. New study reveals down east wild blueberry fields warming faster than Maine as a whole. Now that probably means a longer growing season and better yields for the blueberry fields, but apparently we're supposed to be very frightened about the wild blueberry fields in down east Maine. Let's continue on to talk about the jet streams. So the jet streams are high altitude winds that give us some insight into what's going to happen with your weather. And right now we see some backward jet streams here over places like the western Pacific Ocean. You can see they're blowing east to west instead of the normal mode, west to east. Anyway, those are the jet streams of the eastern world. Here are the surface winds. And we see a powerful low pressure system there to the southeast of Kamchatka right here. How about the surface winds of the western world? There are those. We're on nullschool.net, by the way, if you're wondering what this site is, nullschool.net. There are the surface winds of the western world. Here are the jet streams of the western world. And you can see the eastern Pacific features some backward jet stream as well right there. Jet stream clearly blowing east to west. Next, a real-time lightning map. It's lightningmaps.org. It's where I go when I hear thunder. And we've got some lightning here. In Wisconsin. Hey, Appleton. There's thunder rolling in. Hey, New London. You've got a cell to your southeast. Also, Eau Claire. A very active system there east of Chippewa Falls. And if you catch any interesting photographs of sprites or anything like that, green elves, blue diamonds, purple horseshoes up in the sky, let us know. We see a bit of an increase here in lightning activity as we make the video. Is it a coincidence? Is it divine providence? Is it pure luck? Is it none of the above? You be the judge. Leave us a comment. Let us know what you think. Next on windy.com, we're looking at pressure cells. And check out the very tight isolines here associated with this low pressure. It's likely creating some rough seas around the western Aleutians. Let's just advance this into tomorrow. Here's where we expect things to be at 1 p.m. Eastern Daylight Time tomorrow, according to the GFS forecast. U.S. Doppler Radar Map is next. And we've got a concentrated band of storms here stretching from Nebraska through southern Minnesota, now moving into Wisconsin. That's the source of those lightning storms. Also got some rain on Pennsylvania. And snow is continuing to fall in places like Idaho, Nevada, Wyoming, Colorado, Utah. Some in Arizona and some in California. Continued snow, most likely very wet snow. As you can see, it's associated with rain showers as well. Let's talk about ship tracks. Now, you see that right there? That right there, folks. Those are ship tracks. And guess what ship tracks aren't? Chemtrails. That's right. Ship tracks are not chemtrails. Let me explain what else is not chemtrails. Bulgarians firing rockets at thunderstorms to divert hailstorms to prevent crop loss. Rockets fired at thunderstorms are not chemtrails. Sounding rockets spraying chemicals into the mesosphere in order to study mesospheric winds, those aren't chemtrails either. Contrails around your local airport, where you see planes creating contrails at altitudes below 40,000 feet of altitude, those aren't chemtrails either. Coloradan crop dusting planes attempting to alter the trajectory of snowstorms in order to put snow on their slopes of their ski area instead of on neighboring mountains. That's also not chemtrails. Chemtrails is the proposed and idiotic idea that there is a global, large-scale program of planes spraying chemicals into the stratosphere. Not only do we not have the planes, we don't have the chemicals. It's just not a thing. So the next time you see a contrail, I don't know what to tell you. If you think it's a chemtrail, you're just wrong, and it's an idiotic idea. However, contrails are pollution. They do make the planet cooler, and putting particulate into the atmosphere causes additional cloud nucleation. Now, some of the clouds caused by these ship trails, according to this article, are still affecting things 20 hours later. Why? Because they cause clouds to form in the troposphere. The troposphere. Understand the distinction between the troposphere and the stratosphere. Understand the difference between your you-know-what and a hole in the ground. And realize that these things are increasing the Earth's albedo. They are a global cooling effect. They're reflecting infrared light back into space. And they're also creating shade on the ground. So it's a twofold method. They're also causing more and larger clouds to form. It's ship tracks. Another article you can find in the Sharticle-filled phys.org Earth section. So if you want to check that out, perhaps go ahead. And it's a great time to be doing science because the understanding of how these things work is changing as we speak. Things like the impact of cosmic ray flux on cloud nucleation is not widely understood, although it should be. And let's continue on with the meteorology segment. Here's what's going on in the cloud layer. And let me rock this back and get rid of this article. So here's the Doppler Radar Map, folks. Pay attention to the time and date stamps. Here is the cloud layer map, the shortwave radiation 3.9 nanometers radiation map. Here is the water vapor map. And there is a delineation line right here between warmer and colder air. Although most of the U.S. experiencing fairly warm air right now, as the jet stream is coming down like this. So once again, there's the U.S. Doppler radar map. Here's the cloud layer. And there is the water vapor. And that's today's meteorology segment. See you later once again, Twitch. And for the rest of you Daily Space Weather video viewers, here are a bonus of features. How about the latest imagery from the El Teide, Spain ground-based solar observatory. And you can see there are still some filaments down here in the southeast. You can see this filament that we showed you earlier that moved. It looks like it actually collapsed. We did not see it eject. And there are still some filaments in the north as well. Again, likelihood of solar flares is still significant. We could see an M-class flare come out of that group of sunspots. Thanks to the SMASH team. Thanks to the most important members of the SMASH team, our patrons. Please consider becoming a patron at patreon.com. Thanks to our new patrons who subscribed in April. Even if you're unwilling to open up your cobweb-encrusted wallet and send us $3 per month to see these videos on time, become a patron anyway. At least you'll see when we post stuff. And many of our posts at patreon.com/smashamash are public. You may find it in your best interests to subscribe over there. And tiers start at $3 per month. If you'd like to win a free month of Patreon for May, enter our slam poetry contest details at smashamash.com/forum. And if you want to read about our mission, smashamash.com/forum/mission. Here come the remainder of our bonus features here at Smash News Network, Lee's Busted Name of News. Here are the magnetic fields associated with those 3 sunspot groups. Here are the intensity grams while we did show prep. So about a half an hour ago, that's what it looked like. And this sunspot here is only alpha class. These other 2 are beta class, and the most likely place to see a major solar flare is from this one right here. It's quite complex. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Let's update this to see how it's changed in the past half an hour. And it's been pretty steady here. I believe this lead group here has actually degraded a little bit. In fact, I think all 3 of those groups have degraded a little bit in the last half hour. Anyway, there's the colorized magnetogram. There's the intensity gram. Here are some more images of the closest star. It's 193 angstroms. Here's this coronal hole we were talking about, which for some reason is not showing up in the Gong 2 data. I have no idea why, but there is a coronal hole there. There is a coronal mass ejection on the way to the Earth geospace. We'll see if NOAA is able to update its information today. Maybe they're watching our videos. I don't know. I think they probably should. But in any case, here's the southwestern portion of the local yellow dwarf here in 171 angstroms. Fantastic imagery here of those 3 sunspot groups as well as the setting active region. Just spectacular imagery here from the Solar Dynamics Observatory. And last but not least, here's 131 angstroms. And this wavelength, like 94 angstroms, takes 10 images per minute instead of only 2. So if you want to see the most high temporal resolution of SDO imagery, use 131 and 94 angstroms. In any case, thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo Renaissance. Visit our links, support our channel, and may that solar wind be at your back.